One of my favorite things to talk about in our chemistry unit are exactly what chemical symbols mean, how they're written, and what they look like. Let's take a look at some of those now. So, first of all, we talked way back when we began our unit on the periodic table about the fact that you can see the chemical symbol for an element in your squares on the periodic table. So, for example, this is the chemical symbol for carbon, and you can find it on the periodic table in the cell for carbon. And what I want you to see here is that when we're talking about the chemical symbol for an element, it's always capitalized if it's a one-letter long symbol. So carbon's symbol is just a C. That C is always going to be capitalized when you're talking about carbon as an element. Now, sometimes when you're looking at the chemical symbol for an element, you might see two letters instead of one. Remember that carbon only had one letter in its chemical symbol. Some elements have two letters in their chemical symbol. For example, this is lanthanum, and you can see that there's a capital A and a lowercase a. Well, that represents lanthanum, so if you ever see La, that's what they're talking about. But in this case, I want you to notice that if an element has a two-letter chemical symbol, first letter is capitalized, second letter is lowercase. Okay, so carbon, because it was only one symbol, one letter in its chemical symbol, it only has one capital letter. But elements could have two letters in their chemical symbol, and if they do, it's a capital letter followed by a lowercase letter. Now, here's why that becomes important. Sometimes when you're looking at a chemical symbol, you might see two capital letters side by side. Take a look at the example I've shown you on the screen. It's a C followed by an O, and they're both capitalized in this case. If you ever see that, what it's telling you is you're really looking at the chemical symbol for a compound. So a substance where two elements have joined together to make something new. In this particular case, we're looking at the chemical symbol for the compound carbon monoxide. And carbon monoxide has one atom of carbon and it has one atom of oxygen inside of it. Now, how do we know that this is a chemical symbol for a compound with two elements in it, instead of the chemical symbol for an element that has two letters? Well, the answer is in the capitalization. Because both of these letters are capitalized, what we know is that that represents two different elements. Capital letters are a giveaway to you that you're looking at a new element. So you've got a capital C, that means there has to be an atom of carbon inside of whatever this substance is. You've got a capital letter O, that means there has to be an atom of oxygen in whatever substance this is. The two capital letters are the giveaway for you. Does that make sense to you? Now, the chemical symbol for a compound isn't always going to be two capital letters side by side. It really depends on what elements are inside of the compound. So here's another chemical symbol for a compound. This happens to be the chemical symbol for sodium chloride. We know that as table salt. And notice that it's got capital N lowercase a. That's an element. We know that because the capital N indicates an element and the lowercase a means that those two letters at the very beginning, they go together. That's the chemical symbol for one element. And Na, this chemical symbol, that's the chemical symbol for the element sodium. Now, we know that we have an atom of some other kind of element here, right? Because there's another capital letter. Don't forget, those capital letters tell you that you're looking at a new element. In this particular case, we've got a capital C, lowercase l. Well, guess what? Capital C, lowercase l is the chemical symbol for the element chlorine. So what this formula is telling us is that we have one atom of sodium, and here's its chemical symbol, and we have one atom of chlorine, and here's its chemical symbol. And those two atoms are working together. They've joined with one another in order to make a new compound. Now, I really need you to understand that those capital letters mean everything when you're looking at chemical symbols. You have to be very precise with your capital letters. And here's why. If you take a look at this very first chemical symbol, we've got capital C, capital O, right? We looked at that a minute ago. That's a compound. That's carbon monoxide. It's one atom of carbon joining together with one atom of oxygen. But if you look down here at the bottom, you've got a capital C and a lowercase o. They look really similar, don't they? This guy looks pretty similar to this guy. But there's a big difference that lowercase o is a giveaway that this is not a compound. Instead, this is the chemical symbol for an element. It just so happens to be a chemical symbol that includes two letters. First is uppercase, second is lowercase. By the way, this is the element cobalt. Isn't that wild? This one lowercase letter is the difference between an atom of one element, cobalt, or a compound that includes an atom of carbon and an atom of oxygen. So you have to be very careful with what you're capitalizing and what you're lowercasing. And when you're reading a chemical symbol, you have to really be aware of or notice whether you've got capital or lowercase letters. Capital letters, giveaways that new elements are starting. Lowercase letters, giveaway that you're looking at a chemical symbol for an element that has more than one letter in it. All right, now the last thing that you need to know about is that sometimes you're going to see numbers in chemical symbols too. And you know this, you've seen H2O before, right? That's the chemical symbol for water. Well, in this particular case, those lowercase numbers, those subscripts is what we call them. They're numbers that kind of come below the line. Okay, those subscripts are telling you a little bit about the number of atoms of an element that appear in a compound. Okay, let me say that again. It tells you the number of atoms of an element that appear in a compound. So in this particular case, when we see O2, what that's really telling us is that there are two atoms of oxygen inside of this compound. Do you guys get that? And by the way, we call this carbon dioxide. You probably have seen that before. It includes one atom of carbon, and we know it's one atom of carbon because there's no subscript here. And it includes two atoms of oxygen. Okay, and we know that because we've got the subscript 2 after the chemical symbol for oxygen. Here's another example. It's one we spoke about a minute ago. It's H2O. You guys have all heard of H2O before. It's the chemical symbol for water. That's not a surprise to you. Notice that we know that there are two elements inside of this compound, and we know there are two elements because we have two capital letters. We have hydrogen in H2O, and we have oxygen in H2O. But we also know from this subscript that there are two atoms of hydrogen in a water molecule. And if you look over here, there is no subscript for the oxygen, right? When you see no subscript for oxygen, what it's telling you is that there's just one atom of oxygen in a molecule of water. So subscripts tell you how many atoms of an element there are, and they're always referring back to the element listed before it. So in this particular case, hydrogen is listed and it has a subscript. So this 2 is telling you how many atoms of hydrogen there are in a molecule of water. Okay, so that's how you figure out what chemical symbols mean. I think it's kind of fun.